What is a repeating decimal? I don't like the definition that the book gives for this answer, okay? I like the definition the book gave earlier in the year. So can somebody share with me their answer? If you remember, think back to when we first started talking about repeating decimals. Joel. Okay, it does, yes, it's a decimal that repeats, and that is actually, that's pretty much what the book gave, but the book gave a better definition earlier in the year. Does anybody remember it? Robert? No, it says a repeating decimal has a block of numbers that repeat. And let me give you an example. I'm going to explain to you in this warm-up what I'm talking about. A block of numbers that repeat. So if you guys work this out, you probably know that if you're on top, you're in the house or out of the house? Okay, bottom out of the house. Now, I had some students that struggled with that. This is what this works out to be. Here's the long division. Make sure you check that your work matches this, because I had a few students that mixed the numbers up, and they're confused on which goes in the house and which one stays out of the house. Okay? What I would recommend for those of you that still struggle with dividing and multiplying decimals, make sure you have this written down and make sure that you go work this out so you know how to do this on your own. Because SAT is going to have questions where you cannot use a calculator, and they're going to have you calculating the decimal values. So if you can't demonstrate that, that's an easy task. It just means you have to be thorough. So if you miss this problem, I'm not going to reteach all the steps on dividing decimals, but I did work this out for you so that you could confirm and verify that you got the right thing. Okay? So some of you on the last unit test, I gave you partial credit. You might have messed up a little bit here and there, but you set everything up right. You just had like one thing that was off. And so I gave you most of the points. I didn't give you full points, but I gave you most of them. Some of the students that I'm talking about are in this classroom. Okay, but if you want to get perfect, you got to be perfect. If you're almost there, I'm going to give you almost all the points. Okay? All right. How many of you got this problem? What type of decimal is this? Is this a repeating decimal? What do we call a decimal that is not repeating but has an end to it? Does anybody remember? I try to give you guys an example to remember it. How to deal with trains. Tata? Terminating decimal. Remember I talked about a train terminal? A terminal is like when you're at the end of the trip or start of your trip, and the end. Okay, train terminal, that's where you arrived at the terminal. Does that make sense? So I'm trying to give you guys some examples. So for this next one, take a look. Here we go. There's no bar here, so that means what? It has an end to it. It's a terminating decimal. There you go. Okay, I'm looking around. I see a couple people nodding like, okay, you got this. This is good. Okay, this is all review. Anybody have any questions about how to set up the long division? Okay, we've gone over this many, many times, so I'm not going to spend a terrible amount of time teaching long division. Okay, if you got the wrong answer, copy down the number. Try to verify later at your own time. All right, 4/9. Let's take a look at this. I had a lot of questions about this problem in the last class. There's a bar there that means that what block of number repeats, Alexis?
4.
Just the 4 repeats. Now, are you always going to have just a single digit block that repeats?
No.
Right, you could have more than one digit. It could be 3, 4, 5, 3, 4, 5, 3, 4, 5, and the block that repeats would be 3, 4, 5, and that's what you would have the bar over. Do you guys understand? So if you guys look back to the old definition earlier in the book, it's a block of numbers that repeat is what makes the repeating decimal. So here's the work that goes with it. And I had a very interesting question from a student in the last class. He said, hey, Mr. Hedderly, how do I know later on that there's not a 5 or a 6 somewhere down the line? And I directed his attention here. Do you guys see that I have 4 and I had to put a 0 here, 40, and then a factor of 9 that goes into 40 is 4 times 9, 36. Do you guys see that? And then what I get back is a 4, right? Okay, then I bring down another 0, and then guess what? I'm back to where I started. I have 40 again. How many times does 9 go into 40? 4 times. 4 times 9 is 36. And do you see what I get back? I get back 4 again. That pattern is not going to change. Do you understand? that pattern is going to repeat. That means my numbers in the for my quotient is going to be 4, 4, 4, 4. It's going to continue indefinitely, forever. Now, we don't need to continue this anymore because we already know what repeats, the digit 4. So I put a bar above the 4. Do you guys see that? That means that 4 repeats. Joel, do you have a question? Right, that's what I said earlier. You might have a block of digits that repeat. Okay, so 2/5 or 2/15. Here's the answer. Now notice it's only over the 3, it's not over the 1, right? So the only thing that's repeating is the 3. So it's 0.133333. It continues on. Here's the math that goes with it. And then you could see the pattern here of why it repeats. Are we good? Okay, any questions about that? That's important for what we're doing today. All right, let's take a look what you'll learn. To convert between fractions, decimals, and percents. Why learn this? The food labels below all use a different form of 1/2. Any rational number can be written as a fraction, a decimal, or a percent. Okay? So, the first label, 50% of the minimum daily amount. So, daily amount, I'm assuming whatever, it might be a vitamin C, right? So, there's a recommendation about what you should eat every day and all the nutrients you should be getting into your body every day to remain healthy. So this, whatever this is, this label is, if you have a serving of it, you've got half of your daily recommended amount.
I'm happy to report that our internet is back up. Once again, our internet is back up. Thank you.
So if you look at this middle one, it says same taste, half the sugar. So whatever they had before, they cut the sugar in half. And maybe they put in fake sugar, right? Right? Do you guys know what artificial sweeteners are? Yeah. It's not like real sugar from cane sugar. It's something else. So they try to make it sweet because some people don't care. They're just like, I just want something really sweet. So they put this in there. They're saying, hey, half the sugar. You guys realize that half and 50%, it's another way to represent the same quantity, right? Or same portion. All right. Now, the product has 5/10 of a gram of fat. So this is the decimal value. 5/10 is a way to say half of something, half of a gram in this case. Okay, yes. Yes. Now here's the key concept. This ties in very nicely with what we did yesterday. Fractions, decimals, and percents. The model at the right shows 21 out of 100. Do you guys remember how we read the models? And I had actually, from the students that did their homework in the first period, I had some really good models on graph paper. So if you don't have graph paper, there's places online you can grab graph paper, print it out to have your own graph paper. So if you take a look, we have 2 columns. How many is in each column on a 10 by 10? There's 10. So I have 10, 1, 2 columns. 2 columns would mean I have 20 plus this extra 1, 21%. Okay, as a fraction is 21 over 100. As a decimal, take a look at this very carefully. Do you see what the place value is of 1? What's the place value of 1? What's that place we call? The 100th place. And what's the place value of the 2? The 10th place. But it's 21 hundredths, right? We say the number to the right of the decimal, and then we say the place value of the last digit. So 21 hundredths. Here's the fraction, 21 over 100, 21 hundredths. And then look at the percent. Now remember, if I don't have a decimal, the decimal's at the end, just to the right of the last digit here, 1. Do you guys see that? So if you have no decimal, you can put a decimal between the digit and the percent sign. That's where it is. Well, if you notice, how many places did the decimal move here? From decimal to percent, how many places did it move? It moved 2 places. Now, how many zeros are there in 100? 2, right? So we're going to be using that all day long in this lesson. Remember what I said about multiplying by a power of 10? How many zeros you have is how many places you're going to move the decimal. Okay? Now you got to figure out which way am I going to move it. If you're dividing, you move it one way. If you're multiplying, you move it another way. So now take a look at this. Writing decimals as percents. I want you guys to go ahead and write these two decimals as percents. There's two strategies. I'm going to show you the two strategies. I'm hoping you use the quick strategy, but if not, I'm going to give you a strategy. It might not be the fastest, but it's a good way for you guys to practice a skill that you should know, and hopefully it'll give you an idea of why the shortcut works. Okay, let's walk through this. So take a look. I'm going to give you one strategy. This kind of explains the books. Do you guys notice the place value of the 9, the digits furthest to the right? It's the thousands place, right? The 5 is in the hundreds place, the 7's in the tens place, but we're only interested in the last digit. Do you guys understand? Now I know how to place it as a fraction. It says multiply by 100, right? So if I take a decimal, if I multiply it by 100, then do you guys see that I can cancel out some zeros here? So let me watch. Let me write something up, because I didn't do it the last class, and I feel like I should have. So if you notice, I have 2 zeros here. I'm going to cross cancel. I'm going to cross cancel 2 of my zeros. And so do you see that I'm left with just 10? Do you see why? Because 100 and then 1,000, if I simplified that fraction, it'd be 1/10. Do you guys understand that? So now I got 759 over 10, and that means I could just move my decimal because I'm dividing by 10, right? If I divide by something, making it smaller, so I'm going to move my decimal over one place to get rid of that divide by 10. Do you guys understand that? Now here's the other method. It's a little bit longer. If I multiply by 100, here's what I get in the end. 75900. I have 3 decimal places here, right? 1, 2, 3. Because I have 3 here, I got to move 3 places down here. And so I get 75 9/10. That is my answer. 75 9/10%. Okay, so 2 ways to think about it. Yes? Yes. Any questions about my first example? Who can share with me their answer for the quick check problem? Jaden, go ahead.
I got 60.7%.
Did you guys get 60.7%? That's the answer. Super easy. All you got to do is move your decimal. But let me walk you through it if you didn't understand that. Yep.
So if it's like that, all you have to do is like move the decimal.
Right. I'm explaining why, kind of behind the scenes, why you can just move 2 places. So here you go. Look, the 7 is, again, in the thousands place. So here's a fraction I have. If I multiply by 100 over 1, because going from a decimal to a percent, you're going to multiply by 100. Cancel out my zeros again. That's why I end up with 607 over 10. And then notice I just moved it over 1 place to get rid of my 10 in the denominator. Okay? So the book kind of explains it this way. I want to just clarify what the book was saying a little bit more. But if you just need to know old school method, multiply a decimal by 100, and then you easily convert it to a decimal, 60 7/10%. Okay? Again, after I multiply by 100, I have to keep track of all my decimal places, and I have 3 places that I move here. That's why I move 3 places down here for my final product. Okay? Questions?
Yeah.
What's your question?
I did not exactly get what you got.
Did you multiply by 100?
Mm-hmm.
Okay, you should have got the same digits back, right? Okay. You have to keep track because the decimal number you multiplied by had 3 places. So you have to move it over 3 places. But are you talking about these set of zeros here? Okay, so let me walk you through this. 0 times the first zero here times this, it's all going to be 0, right? But then I have to put in a placeholder. I got to put a 0 here, and then I got to multiply the next 0. Well, all I'm going to get back when I multiply this 0 is another set of zeros. But now before I multiply that 1, now I got 2 place values I got to deal with, right? And then I can multiply the 1. Now I'm going to get these digits right here. All right, and then when I take the sum, that's what I get in the end. Move the decimal place. Okay. Some of you might recognize that if you understand multiplying in decimals, you might recognize that because I have the zeros, as long as I'm keeping track of my place values, I don't have to do those, right? Okay, but just make sure when you do get to a digit that's significant, you got to know where your place value starts. Okay, any questions?
Wait, well, why don't you do the other 0 down?
Oh, because when we multiply a first number, we don't have to put a 0 there.
But why did you do the other one down?
Because when I went to the next one, then I had to start over 1 place. That's why I had to put that 0 there. Okay, and then,
Like at the bottom.
oh, because I don't need to put a 0 in front of it, because this is a whole number. Okay, I could have. You're right. I could have put the 0 there. Right? But do you see where my decimal is going to be? Right? Does that make sense? So it's going to be a whole number. If I put, you wouldn't put a 0 in front, like a number, give me a number, any number. 25. Okay, if I put 0 in front of 25, do I need that 0? Would I say 0, 25? Do you understand? That's why I didn't put the 0 there. Okay? Okay, moving along. Any questions? I can move along. Okay. To write a percent as a decimal. Now you're going the other direction. We went from writing a decimal as a percent, right? Now we're going to write a decimal percent as a decimal. So you're doing earlier we multiplied by 100. Now we're going to divide by 100. Okay, so think about the direction we move our decimal now. Okay, let's walk through this. So when we multiplied, we move our decimal which way? If I'm multiplying by 100, I'm making it bigger, right? So I move it to the right. Okay, if I divide, I'm making it smaller, so I move it to the left, right? Okay, so let's think about that. We multiplied by 100. We're making it bigger. We moved it. How many zeros are in 100? 2, right? So if we're dividing by 100 to go from a percent to a decimal, we're going to move it 2 again, but this time to make it smaller to the left. Okay? So let's go ahead and take a look at this. You guys see how I got that? right? Because remember, percent means per 100, right? So I got rid of my percent sign because it's per 100. All right, well, now that I have per 100, now I can rewrite that. Because per 100 means I'm really dividing. And if I'm dividing, I'm moving it how many places? I'm dividing by 100. How many places am I going to move it? 2, because we got 2 zeros. And when I'm dividing by 100, am I making it a bigger number or a smaller number? So I'm going to make this a smaller number. I move it 2 places to the left. Do you guys see how I got rid of the 100? Because I moved the decimal 2 places to the left, right? Do you guys understand? All right. Now, that's my answer, but if you need to work it out and go ahead and divide this out, because some of you guys brought this up yesterday, I can just divide. I don't need those shortcuts. That's the long way. Okay, do you guys understand? So if you're on top, you're in the house. So you see that I have 47 5/10 in the house, right? If you're on the bottom, you're out of the house. So if I do my long division and I do it correctly, that's what I end up with, the same thing. Okay? So this method takes a lot longer. But this method, I want you to use that to understand why you can just move your decimal. Do you guys understand?
So
Okay. Yep.
if you divide it, you can move it to the left.
You move it to the left however many zeros you have. It's only if you're dividing by a power of 10. So 10, 100, 1,000, however many zeros you have is how many places you can move. Okay, it doesn't work for just any number. It has to be a power of 10. Okay. Now, you guys should know the shortcut. Go ahead, write these down, do these. You should know the shortcut. If you don't know the shortcut, then you should go ahead and do it the long way. Yes? Good. Most of you are practicing this. You're writing it down, so you'll probably remember it. Those of you just watching this like it's TV, you're probably going to forget it. You're going to walk out of here, you're going to say, oh, that was so easy. Tomorrow morning when you wake up to watch cartoons, you're going to forget everything that we worked on today. Don't look sideways. There's half of you probably get up in the morning and watch cartoons. Eat your cereal. Yeah. Okay, some of you guys are nodding. Yeah, I'm not. I'm not saying all, but there's quite a few that that will. So let's not play games. Yep. Yeah, go ahead. Okay, focus. Get this done. It shouldn't take you long. When you're done, put your pencils down so I know I can continue. What's your question? That's an 8. 7 and 8/10%.
Still 100.
Okay, it looks like most of you are just about done. I'm going to give you guys about 30 more seconds to finish this. And I'm going to show both methods. Okay, so everybody should be done with the first one. Here you go. Wrote that as a percent, 35% per 100. Okay. Now, if I'm dividing by 100, I'm moving my decimal place how many places? 2. And which way am I going? Left. So do you see how I got this? Are we good? Now, if you need to see that we can divide this and get the same result, here it is. So 35 is in the house, 100 is on the bottom, it's out of the house. When I divide it out, that's what I get. There's my answer. Yep. Okay, what did you get for the next one? 125,000. Right, thousands. So here it is, very good. So I take my percent per 100, 12 5/10 per 100, here it is. Now, I'm dividing by 100 again. That's what a fraction is. I got 2 zeros, I'm going to move it 2 places to the left. So that's why it ends up in front of the 1. You guys understand? So it's 125 thousandths. If you need to see me verify it with long division, here's the long division. That is your answer right here. This is easy. Remember I told you, out of all the units this semester, if you have an ace one, this should be the one that you ace. Okay, who wants to share this one with us? A little bit tricky, but not really. Chin, go ahead.
I think it's 78 hundredths.
Not hundredths.
Oh yeah, 2
Tell me the digits. Explain the digits to me.
0, 7, 8.
Where's my decimal at? So tell me the digits with the decimal.
Decimal 0, 7, 8.
Okay, very good. So you said decimal 078. Well, that is, the 8 is in the thousandths place. So it's 78 thousandths. So you say the number, and then you say the place of the last digit, 8. So it's 78 thousandths. Okay? So if you need to see that verified here, here's my long division. There's my answer. Very good, Chin. Okay, any questions? This is super easy. In a moment, I'm going to collect your homework. It sounds like a lot of you did your homework. Good. Wasn't it easy? Okay. So I scratch my head when I have a class and like a quarter of them do the homework. Like, I'm kind of blown away. Maybe you guys could talk to the other class about that. Now, moving along. Let's go ahead and read through this. Now, listen, a lot of you struggle on the word problems. Because I'm putting this up on the YouTube channel for the class, I'm going to go ahead and read this. When the denominator of a fraction is a factor of 100, you can easily use equivalent ratios to convert the fraction to a percent. For fractions with other denominators, you can use division to convert the fraction into a decimal and then rewrite the decimal as a percent. So let's take a look at this. Writing fractions as percents. Okay, sometimes you will have to do long division. Okay, sometimes you won't have to do it. Let's take a look. Nutrition. In a slice of cheese pizza, 45 calories are from fat. You have to be careful about the way you read this. This should remind you of what we did yesterday. The total number of calories in each slice is 158. About what percentage of calories are not from fat? Do you guys see? I even changed the font. I made not italic, so you guys would pick up on that. Round to the nearest tenth of a percent. So you're going to have to divide this. And if we're going to round to the nearest tenth of a percent, we got to divide how far? You got to go one extra place over, right? So what is next to the tenth of a percent? Thousandths of a percent. Okay, try. Whatever you think, try. This is where you guys try, okay? And then we'll discuss your strategy. If you got the right one, if you had a strategy that gets the right answer, we can discuss that. If not, hopefully we can iron out your idea of what the problem's asking. Can somebody share with the class what's going on? Somebody have a strategy here? Remember, you don't have to keep dividing forever. Khadijah. So what did you get for your ratio? No, I don't think that's it. Can somebody share with the class, explain how you got your ratio? Give me your fraction first. That's the first thing you need before you can start calculating things out. Alexis?
5 over 158.
Okay, so Alexis, you can get to the answer that way, but if you put 45 over 158, you're finding the percentage of fat. Do you understand? But that's not what it's asking. It's asking for the percentage of calories not from fat. So if 45 calories are from fat, and altogether we have 158 calories, we need to figure out the percentage not from fat. How do we find the percentage not from fat?
158 over 45.
Can somebody help him out? Think about yesterday's problem. Miranda?
You have to subtract the amount of fat from the total calories.
Very good, Miranda. You have the total calories 158 altogether, right? They're saying 45 of them are from fat. They want to know how many are not from fat. So we need to figure out how many calories there are not from fat. Well, we did that by subtracting 45 away from the total calories. You understand? That's how we got 113 calories. Does that make sense? So that's not the answer. We got to figure out the percentage. So now we got to go from a fraction to a decimal to a percent. Do you guys understand? Yep. And you're expected to do it as 7th graders. It's a lot of work. Good. I see some of you guys trying to crank this out. Nice. Now, Alexis, you can save your work if you found the percentage, right? If you found the percentage with that, you found the percentage of calories from fat, okay? So if you found the percentage of calories from fat, you could find the percentage not from fat by subtracting your result from 100. Remember like we did yesterday? You can subtract that from 100, then if you did it right, if you calculated the percentage from fat correctly, then you'll have the correct answer for a percentage not from fat. Yeah. Yes, very good. So Miranda's question is, are we supposed to turn this into a decimal? And yes, turn it to a decimal, and then you turn it into a percent. Robert? I think you might have messed up. I'm going to go ahead and review the answer because I see a lot of you have started working this out. Check your work. Here it is. Now, if you notice, I went over to this 10, hundreds, thousands, 10,000s place, and the reason why, if I make this into a decimal, do I get a 1/10 of a percent? Where do I have to move this over to make this decimal into a percent? I move it over where? To the right. Now, if you notice, that's not really the answer. It said the nearest 1/10 of a percent, right? So I needed the hundredth of a percent. And why did I need a hundredth of a percent? Because I have to know if I round the 1/10 of a percent up a number or keep it. Am I going to round the 5 up or am I going to keep it? Keep it, right? Because 1, it's not 5 and up. So the answer is 71 and 5/10%. So you have to know how far to divide. In this case, I had to divide out 4 places, right? Because I was going to move it over 2, and I needed to have enough figures so I knew how to round my 10th place.
I got 68.4.
Okay, might have messed up your calculation, but there is a way to get to the answer using your strategy. Okay, now, next problem. This one's a little easier. Write this as a percent. Round it to the nearest 1/10 of a percent. Some people are just getting started, so I want everybody to Oh yeah, what's up?
Why'd you put 5 for 715? Just put 5. Actually 6. Oh, wait.
Did I mess something up? So I could have kept dividing, Noah. I stopped after a certain point. After I had enough digits, significant digits, I stopped. I think I see what you're talking about, Noah. You want to help me fix it? So just a little review, because there is a typo here. 7 times 158, is that correct? 1106. Okay, so then I subtract, I have 24 left over. Sorry. And then 1 times 158, 240 minus 158, that gave me back what? 240 minus 1. So 2 more, 82. And then bring down the 0. And then 5 times 158, what was that going to be? 40. Carry the 4, 25, plus 4, 29. You said 790, right? Okay, and then 790 from 820 is going to be what? 1030? Okay. 790, right? And then 820 minus 790, so 10 more gets me to 800, plus 20 more gives me 30. And if I brought down another 0, right, I couldn't go 2, right? That'd be too much, so I'd have to go 1, so that would have to be 1. All right? So there's, yeah, made a mistake. We fixed it. Okay, but the result was the same. Yeah?
Why is it 9? Oh, because the 2 is less 2 turned into 4.
Yeah, are we good? Good catch, Noah, thank you. All right, can we go on to this last problem right here? All right, there's my ratio. Did you get something? What'd you get? 5 and 25 thousandths. Very good. So this is not a repeating decimal, right? How many of you guys got that? Okay, good. So this was a little easier than the example. My answer, I got to move it over 2 places. That's my percentage. Are we good? Okay. Somebody said earlier, like, that's doing a lot. Is it doing a lot? You guys know the steps, at least? That's not the answer? To the nearest 1/10 of a percent. But that's the thing. Interesting. Good question. It says nearest 1/10 of a percent, but guess what? I don't have any more digits because I have a terminating decimal, right? Noah? Okay, did you get the same answer? Okay. There are more than one way often in math. I want to get through the lesson and cut you guys loose on the homework. So let's move ahead. You guys understand the step to go from a fraction to a decimal to a percent. Do we understand what's going on with that? Okay. Moving along. You can write a percent as a fraction. First, write the percent as a fraction with the denominator at 100. Then simplify the fraction. So anytime you have a percent, remember the percent means per 100. So I can always get rid of the percent by putting that number in the numerator over the number 100 in the denominator. You guys understand? Because percent means divide by 100, basically. Got it? So here, behavioral scientists observed an elephant that slept 12 and 5/10% of each day. They want to know what fraction of each day did the elephant sleep. So first step, what's the first step? Who can tell me the first step? Make it into a fraction. So if I make this to a fraction, my numerator is going to be the 12 and 5/10. My denominator is going to be what? 100, because percent means per 100, divide by 100. So here it is. Now this goes back to what we did earlier. If you notice I'm dividing by 100, how do I get rid of the 100? How do I get rid of the 100? I'm dividing by 100, right? How do I get rid of it? Well, look at what I ended up with, right? Think about, thank you, Nima. Did you hear what Nima said? I moved the decimal. Because I'm dividing by 100, remember if I multiply by 100 or divide by 100, how many zeros are on 100? 2. So how many places am I going to move my decimal? 2. Now I just have to decide when I multiply, which way am I going to move it? When I divide, which way am I going to move it? Well, here I'm dividing by 100, right? So I'm going to move it 2 places, but when I'm dividing by 100, am I making something bigger or smaller? So which way am I going to move my decimal? To the left, right? So it was here, between the 2 and the 5, so 1, 2. Do you see why the decimal ended up here? Do you guys see why the decimal ended up there? And why we got rid of the 100? Do you guys understand that? Okay, and then now, what is this number? 125, what's the place of the 5? Thousands. Do you guys see how I got that fraction? Does that make sense? Okay, now we have a fraction, but if you get this, this will probably be one of your answers. It'll be the wrong answer. Because when we have a fraction, they want it in simplest form. So I'm going to tell you right now, the GCF of 125 and 1,000 is 125. 125 will go into 1,000. 125 will go into 125. No remainder. That's what GCF is, the greatest common factor, the largest number that will go into both numbers without a remainder. Yes? Yes. So now, take a look at this. Because the GCF is 125, I could simplify this fraction, and we know how to simplify a fraction when we know what divides in the numerator and the denominator. What's my new numerator going to be? 1, because 125 divided by 125 is 1. And how many times will 125 go into 1,000? Let me talk to you about this in money, because a lot of you guys seem to get math really well when you're talking about money. If I have $1.25, how many piles of $1.25 will I need to get to $10? How many piles will I need to get to $10? Well, if I have $1.25 and I have 2 piles of $1.25, how much do I have? I have $2.50 now, right? Okay. So $2.50, 2 piles of $1.25, right? So if I take 2 more piles of $1.25, that's $2.50 again, right? So how much is that? $5. 4 piles of $1.25 gave me $5, right? So how much do I need to get to $10 if I have piles of $1.25? 8, right? Because 4 got me $5, right? Because 2 piles gave me $2.50. 4 piles give me $5. So if 4 gives me $5, 8 will give me $10. So 1,000 divided by 125 is what? It's 8. So here we go. Now that's not my answer. That'll get you most of the points on the BCR. Remember? Some of you guys lost points because you forgot to what? Label the units. So make sure you explain your answer. The elephant slept about 1/8 of the day. So people are supposed to sleep about, their recommendation I think is 8 hours a day. Yes. So what's the fraction of the day that humans sleep? How many hours are there in a day? 24. So 8 24ths. Let's simplify that. 1/3. We sleep a third of the day, so we sleep more than elephants. No, we sleep more than elephants, right? So let's take a look. An elephant eats about 6% of its body weight in vegetation each day. Write this as a fraction in simplest form. So I gave you the example up top. Now you guys need to figure this out below. I got some people are these people with answers? When he returns. I would like to hear from somebody different. Who else can give me an answer? Who can walk me through this? I've already heard from you. Want to hear from somebody different? So class, what's the first step? Okay, not turn into decimal. We got a step before that. Make it into a fraction. So I heard over here. Who can tell me what is the fraction going to be if I turn this percent into a fraction? Shh. I need a volunteer. Somebody share with me. What is the fraction going to be? Can I get a volunteer to tell me what the fraction is going to be? Somebody I haven't heard from would be nice. Alexia, if I turn 6% into a fraction, what would that fraction be? 6 over 100. Boom. Here we go. Now, because I'm taking 6 and I'm dividing by 100, I'm moving my decimal place how many places? 2. Which way? To the left. I'm making it smaller, right? Okay, so do you guys see that? What is this number now? Say this number right here in the numerator. 600s, because 6 is the number to the right of the decimal, and 6 is in what place? The 100 place. So do you see how I got the fraction 600s? Okay, I see a Tisha. You bunching your face up. Are you stuck on this?
No.
You understand what we're doing? Please stop playing around. Yeah. Now, what's the greatest common factor of 6 and 100? 2 is the biggest number. 3. What are the factors of 6? 3 and 2, right? Can 2 go into 100 without a remainder? Yes. Can 3 go into 100 without a remainder? No. Can 2? So the GCF is 2. Now, because we have the GCF, you know how to simplify this fraction. It's super easy. Simplify this fraction, please. And can I get somebody to share with me the answer? Somebody I haven't heard from yet. Marcellus, we know the GCF of the numerator and the denominator is 2, so I need to simplify this fraction right here. What's that fraction simplify to? 3 over 50, very good. Here it is, there's the work behind it. Easy? But that's not my final answer, right? I have to explain it and have units with that, right? So what's my final answer? I need to label my answer. Can somebody use that quantity, that fraction, to explain the answer to the question? Jacardi, can you give me the answer? Because that's just a number. I want the answer. Read the question and use that fraction to give me the answer. Read it to yourself and then just give me the answer with the fraction there. Right. Jakari says, an elephant eats 3/50ths of its body weight each day. I actually went in a little more detail, but that would have been full points right there. An elephant eats about 3/50ths of its body weight each day. And you could have gone in more detail and said in vegetation. Okay? Question? Could what? No, that's not the same. 3/5 is not the same as 3/50ths. Completely different fraction. 3/5 is a lot more than 3/50ths. Right? So if we have 2 pieces, I cut one pizza into 5 slices. I cut another into 50 slices. I'm going to give you 3 slices of the pizza that I cut into 50 slices, and then I'm going to give you 3 pieces from the pizza I cut into 5 slices. Which pieces, how much, you got more from the one cut into less parts, right? Does that make sense? So 3/5 is not the same as 3/50. You understand? Okay. All right, now, we already did this earlier in the year. So we're coming back to this, ordering fractions, decimals, and percents. Okay? Now we're throwing percents in there. So you already know how to order fractions and decimals. Now you got to do fractions, decimals, and percents. So to compare rational numbers in different forms, you can write all numbers in the same form. Then graph each number on a number line. So the example, I'm going to do the example for you, and then I'm going to have you guys do these examples below. So take a look. So I want to get all of these in, because they want me to put it on the number line, and the number line they gave me was decimals. I need to get everything in decimal form so I can compare them. Well, this one's easy because it's already a decimal, right? And then that's going to be somewhere right about here. Do you guys agree? On the number line. It's just below 2, right? 2/10. You see where I graphed it? Now the other number, so they gave me that one. I have another number that's a decimal. It's 52 hundredths. I'm going to go ahead and put that on the number line. So it's a little bit more than 5/10, right? Do you guys see where I graphed it? Okay. Any questions about what I have so far? So I graphed the easy ones, the ones that are already decimals. Now the other ones I have to turn into a decimal. So do you guys see 37%? You guys know how to mentally figure out what that is as a decimal, right? What is 37% as a decimal? Can somebody share with me what it is? Mason, go ahead. 0.37. Very good. Or 37, what's the correct way to say it? 37 hundredths. So if you look, here's 3/10. 37 hundredths is almost 4/10, right? So I put that over here somewhere, right? Okay, so you guys see where I graphed the next point. Are we good? Now I got the last one to take care of, 1/4. You probably know that mentally already, but I'm going to go ahead and walk you through that. Who can tell me what it is as a decimal? 2,500. So here I'm going to go ahead and show it to you. Look, 1/4. Remember what we covered yesterday? Rewriting a fraction as a equivalent fraction with 100 in the denominator. So what do I multiply by 4 to give me 100? 20, not 20, that's 5 times 20 gives me 100. 4 times what? 4 times 25. So 4 times 25 gives me 100. So I also have to multiply the numerator by 25. So 1 times 25 is 25. And this is easy to write as a percent because it's over 100, right? And then we know a percent is easy to write as a decimal. So here's what we got. On the number line. Do you guys see where I graphed on the number line? Now we have the order. And here's my answer. So my first point was 19 hundredths. The next point was 25 hundredths, or 1/4. The next point was 37%, or 37 hundredths. And then the last one was 52 hundredths. Okay, any questions about those? Now, the next problems, I don't need you to graph these. I just need you to order them least to greatest. Go ahead. Order those from least to greatest. These two problems. And this is the last slide before we wrap it up. When you're done, put your pencils down so I know to go over the solutions. Okay, who can explain the first problem? What was your order? Well, first of all, let's convert all these to decimals, okay? So the first one, if I converted 3/10 as a decimal, what did you guys get back? Or actually, 30 hundredths. No, that's correct. I've made these all percents to compare it. So in the end, you have to make sure that they're all the same thing. So that you could have said 30 hundredths or 3/10, right? 0.3, right? That one was easy to make as a percent, or I could have kept it as a decimal. 11/25, what was that as a decimal? 44 hundredths. I made it a percent, but you could have made it a decimal and then compared all the decimals. And then the last one, well, that was already a decimal. I made it a percent again. So now that I have all these in percents, it's pretty easy to compare them, right? 29, and then this one was the next one, which was 3/10. And then we had 11/25, which is 44 or 44 hundredths. That was next. And then the largest one was 74%. Okay, any questions? So if you converted them all to decimals or you converted them all to percents, as long as you have the same thing to compare. Do you guys understand? Okay. Who can explain their solution for this one? Alexis. What was the smallest one? 8 hundredths, right? Yeah. Okay, what's your next smallest? 15% or 15 hundredths, okay. And then what? 7 over 20 or 35 hundredths. You guys get 35 hundredths for 7 over 20? And then the last one? 50%. That's correct. Again, you could have made these all decimals or made them all percents. I made them all percents. Pick the one that's easiest for you, because when we're taking a test or quiz, time management is very important. Yep. Yep. After that person gets back. Okay, next one. Last slide. Actually, Nima, I'm almost done. Can we wait? We're just about finished. Write the shaded part of the model at the left as a percent, a fraction, and a decimal. Who can tell me what this is as a percent, fraction, and decimal? Michaela? What's this as a fraction? 62 over 100, right? And then how do I write it as a percent? 62%. How do I write it as a decimal? 0.62 or 62 hundredths. Are we good? Any questions? Now, here's what I need you guys to do here. They want you to compare these set of numbers, and they want you to find which one is not equal. Which one is not equal? Carlos, can you give me the answer for the first one? You said 9.9 is not equal. That's correct. Let's take a look at what 9.9 is. So here I wrote this as a decimal, as a percent. I wrote this as a percent. That's not the same as 9 9/10%. Do you guys understand? That's not the same. That's why I X'd that out. Okay, for the next one, let's try to compare all the same things. Let's write all these as percents. This one's easy to write as a percent, right? What is that as a percent? 64%, right? What about this? How do I write this as a percent? That's a skill we learned yesterday. Make the denominator 100. So what would this be if I wrote this as a fraction where the denominator is 100? 32 over 100 or 32%? So which one does not fit this set? 16 over 50. It's easy, right? Okay, let's do the next one. Who can volunteer for the next one? Jakari, which one do you think doesn't match the set? 1 2/10. So that's correct. Let's convert 1 2/10 to a percent. That's 120%. If I move it over 2 places, 1, 2 to make it a percent, right? It's 120%. And then this goes back to what we did yesterday. It's got 25 in the denominator. I need to make it a fraction where the denominator is 100. And I already hear some of you saying 4. So what's my numerator going to be? 12. So what's the percentage going to be? 12%. Very good. So 12%. This is also 12%. This is not 12%. That's 120%. Just like Jakari said, correct. All right, now, they want you to use mental math to order this least to greatest. I need your help. Somebody tell me what the order is from least to greatest. We're almost done. Yes, you can. I would love to hear from somebody I haven't heard from yet. I already have somebody in mind. Yeah. Let's order this least to greatest. So, Atisha, can you tell me, what do you like working in? Do you like converting everything to decimals? Or do you want percents? Okay. So what's 5400ths as a percent? 54%. Okay. We already have 55%. What's a half as a percent, Atisha? Make the denominator into 100. What takes me from 2 to 100? 50, right? So if I multiply 2 times 50, I get 100. If I multiply 1 times 50, what do I get? 50. So I got 50 over 100, and then that equals what percent? 50%. So, Atisha, can you tell me least to greatest, what do we have here?
First 54, then 55%.
No, look, we have 50%. That's smaller. Then 54, then 55. Very good. So my answer, 50, 54, 55. And then the last one, shh, we're not done yet. Have a seat. Right, and we haven't done that. Shh. When you write a decimal, or percent as a decimal, why do you move the decimal point 2 units to the left? Who can explain that? Gabby? Because there's what? For zeros from what? From a power of 10. And what is the power of 10 that we're talking about? Are we just using any power of 10? What power of 10 are we using when we're converting? Not 10. We're moving 2 places, so what power of 10 is it? Can somebody help her out? 100. It has 2 zeros, so 2 places, 100. So the answer is you're dividing by 100. It is a power